YouTube channel. So last time you guys met Gizmo, and this is Lexi. Say hi, Lexi. So Lexi is a girl and she is Gizmo's sister. We're currently hanging out at my in-laws' house so that Gizmo can have someone to run around and play with. This house is also bigger so that, he's got room to run around and whatnot. But anyway, today's video isn't about my dog's play dates, but today's video is going to be more practice on radicals. So what you're going to want to do is take out a scratch sheet of paper and a pencil while I go ahead and put Lexi away. Alrighty guys, so I hope you have a scratch sheet of paper and a pencil just in case you forgot what one looks like. It looks just like this, okay? I'm gonna piece out in this little box right here, but we're gonna go ahead and go straight to our notes. Alrighty, so we're gonna go through a couple different skills, and if you wanna know and look so that you can set up your scratch sheet of paper, we are gonna review 2 skills and then practice 1 new one. So a total of 3 skills. And we're going to do a couple of examples for each one. So you can see up along the top of my paper here, I have my perfect square numbers listed out. That's going to come in handy in a little bit. And then skill 1, we're just practicing simplifying radicals like we've been doing. So I want you to hit pause on this video and I want you to try simplifying these first 4 problems on your own. And when you come back, we'll start doing them together. Okay, welcome back. So to start simplifying, remember, I am going to look for 2 numbers that divide 12, and one of those numbers has to be a perfect square number. So since I'm looking for 2 numbers that multiply to 12, I know that 9 goes into 12, but it doesn't divide it nicely. And you know what? 4 divides 12 nicely. So 4 is going to be one of my perfect square numbers, and then 4 times 3 gets me 12. Okay, and then from there we can simplify. So the square root of 4 is 2. The square root of 3 is not so much a nice number, so it's going to stay underneath the radical, and you are done. Okay, for number 2, we're going to follow a similar structure. 2 numbers that divide 75 nicely. I'm going to start over here at 64. 64 won't work. Neither will 49. Neither will 36, but you know what? 25 is going to be the number that works. So 25 times 3 will get me to 75. The square root of 25 is 5, and square root of 3, again, is going to stay underneath the radical. All right. So for 18, 2 numbers, I'm yawning, that divide 18 nicely. It looks like 9 is going to be the number that we are looking for. So 9 and then 9 times 2 gets me to 18. The square root of 9 is 3. Square root of 2 stays underneath. Okay, so now we get to this next one. So 98. 2 numbers that divide 98 nicely. It looks like that's going to be 49. So 49 times 2 gets me to 98, and that 11 is going to come down. Now the square root of 49 is 7, so I really have 11 times 7. Oh, I don't know why that went away. 11 times 7 times the square root of 2, and then we're going to go ahead and simplify this outside part here. So 11 times 7 is 77, root 2, and we are done so. All right. So now let's go on to skill number 2, which is adding and subtracting radicals. So looking at number 1, I cannot immediately add the square root of 12 plus the square root of 75 because they're not like terms. But what I am going to do is I'm going to break both of them down, and I'm going to see if I can get both of them to have the same number underneath the radical. So we already simplified the square root of 12, right? That got broken down into 4 and 3. 75 got broken down into 25 and 3, okay? Square root of 4 is 2, that root 3 is going to follow. Plus, square root of 25 is 5, that root 3 is going to follow. Oh, once I've broken them down, I've got, for lack of a better term, like terms, right? Because they both the 2 and the 5 have a radical 3 attached to it. When you guys are adding these things, you don't add the number underneath the radical. Okay, so think of it something like, if you have something like 2x plus 5x, your answer is not going to be 7x squared, right? No, your answer is going to be 7x. It's a very similar idea here, guys. So we're just going to add the numbers in front, which is just the 2 and the 5. So the 2 and the 5 added together become 7, and that root 3 is just going to come down. So your final answer here is 7 root 3. Now for number 2, this first term right here is already simplified. I cannot simplify it even more. Oh, this root 12 keeps popping up, so we should be really good at simplifying the square root of 12 by the end of this video. So we should have 6 root 3 plus, we simplified square root of 12 to 2 root 3. And this last term here is just going to come along because it's already been simplified. So plus root 7. Okay. Taking a closer look at this, the only like terms I have are 6 root 3 plus 2 root 3. So 6 root 3 plus 2 root 3 is just going to give us 8 root 3, and then that plus root 7 is going to come down, and I cannot simplify this further. This is your final answer. Okay, so what I want you guys to do next is for number 3 is hit pause on this video, try number 3 on your own, and then hit play and we'll work through the solution together. All right, guys, welcome back. So let's work through number 3 together. So square root of 18. So let's break that down. So square root of 18 can be broken down into root 9 because that's a perfect square number times the square root of 2. And then plus 5, and let's break down 32. So the only perfect square number that goes into 32 nicely is 16 and 2. All right, let's start simplifying. I can simplify this root 9. So root 9 becomes 3, root 2 plus 5. Square root of 16 is going to turn into 4. So I really have times 4 root 2. So that's where that 4 comes from. Okay, guys. So I took the square root of 16 and that became 4. Okay, so let's go ahead and simplify this further. That first part, 3 root 2 stays 3 root 2 plus, and now I'm going to multiply the 5 and the 4. So 5 times 4 becomes 20. And that root 2 is going to come along for the ride. All right, now I've got like terms. I add the 3 to the 20 because they have the same number underneath the radical that's next to them. So 3 plus 20 is 23, followed by root 2. And that's your final answer. Okie dokes. Let's go ahead and keep on trucking along to skill number 3. Okay, now before we start talking about skill number 3, let's talk about, let's give some context here. So if we have something like the square root of 16, the number underneath there, like Miss Gilroy talked about, is called the radicand. Okay, there is another number here, and this number here is called your index. If we are just talking about the square root sign, the index here is 2. And so really, if we see something like this written down, what we're really asking is what number times itself 2 times will be 16. And we already know that the answer to this is 4, right? And so that 4 is basically saying, or that 2 is basically saying, hey, if I have 4 and I multiply it 2 times, I'll get to 16. So now if we apply that to the square root of like something like k to the power of 2, there are 2 ways that I can do this, right? So one thing I can do is, well, actually, I don't want to talk about the 2 different ways here. Let me ask you this question. What times itself 2 times will get you to k squared? Well, I know that k times k gets me to k squared, so the square root of k squared is just going to be k. And that's your final answer. Okay, now let's move on and take a look at number 2, where we have something like w to the 4th power. So one thing we can do here is expand this. If I have w to the 4th power, I know that I have 4 copies of w, right? Now, because I've got a square root symbol here, I know that my index is 2. So what I'm going to do is circle groups of 2. So I've got w and w, right? And I'm going to take one w from each group that I've circled. So I've circled this group in yellow and this group in blue. I'm going to take one from each. So this first one comes from the first group that I circled in yellow. And that second one that I'm writing down comes from the second group that I've circled in blue. So your final answer here is w times w, which simplified is w squared. So this is your final answer for the square root of w to the 4th power. The other way that we can do this is if I rewrote the radical as a power to a power of 2. So I want to put something in my parentheses here so that when I square it, I have w to the 4th. If I have w squared, that's equivalent to w to the 4th power. So basically, this right here that I'm underlining in pink is the same as this that I had in my original Radican, right? And I already know that the square root of a power of 2, I'm just going to take this base here. Sorry about the dogs barking, guys. I don't know what's going on outside. Okay. And so we can kind of streamline our work here. And if we rewrite it as w squared, we can take the square root and it'll just be w squared. Okay, so either way, we get the same answer. Now let's take a look at something like x to the 5th power. So if I have something like x to the 5th power and I want to rewrite it as something, so x to some power squared. Well, how many times does 2 go into 5? 2, right? So I can do x squared, but that only gives me 4 copies of x, and I have 5 in my original radical, so that's why I'm going to write an extra x right there. Now what I can do from here is break it apart like we've been doing. So I can break this apart into x squared, and then this following x right here. I'm going to take the square root of this first one here. The square root of x squared is just going to be x squared. I don't have enough copies here of x to take out another x, so it's going to stay underneath the radical. And this is your final answer. Okay, now let's take a look at something like y to the 11th power. Similar method. So let's go ahead and try rewriting it as y. How many times does 2 go into 11? Nicely. Yeah, so 2 goes into 11 5 times nicely. But really what I have written here so far is just technically 10 copies of y, because if I expand this, I have 1, 2, 3, 4, 5, right? And I have 2 copies of that. So far I only have 10 copies, so I need to write one more extra, which is why I'm going to write one more here. Then I'm going to break this apart even more. So I have y to the 5th squared. That other y is going to come down by itself. The square root of y to the 5th squared is just going to be y to the 5th. So I really have y to the 5th, and I can't take that other y outside of the radical because I don't have another copy for me to grab. Okay, again, if I'm trying to expand this, the other way that I showed you guys before is if I just write out all 11 copies, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to start off by circling groups of 2. So 1, 2, 3, 4, 5, right? And I'm going to take 1 from each of the groups that I've circled. So I'm taking 1 from this group, 1 from this group, 1 from this group, 1 from this group, and 1 from this group. So I have a grand total of those that come out of your radical. This last one doesn't have a partner to come out of the radical with, so it needs to stay underneath. So again, I can go ahead and simplify. I have 5 copies on the outside, so I can condense that as y to the 5th times the square root of 5. Okay, either way, you're going to end up with the same answer. So I want you guys to hit pause, and I want you to try this challenge problem. All right, welcome back. So I can see right now that there are 3 parts to simplifying this radical. So the first thing that I want to do to make my life just a little easier is break this apart into the numbers and the terms that are the numbers, and the variables. Okay, so I've got 3 radicals. I already know how to simplify the square root of 27. I need to look for 2 numbers, one of them being a perfect square number that divides 27 nicely. So the only numbers that work are 9 and 3, because 9 times 3 is 27. Okay. Next thing I want to do is take a look at the x's. And if we look above, we did an example similar to this, but it was with k. So the square root of k squared was just k. So the square root of x squared is just going to be x. And I don't need a radical after that. Okay. And then for our final one, we're going to go ahead, and I'm just going to go ahead and expand that. I have 7 copies of y underneath the radical. So I have 1, 2, 3, 4, 5, 6, 7. Let me just expand this so that it's clear that all of those are underneath the radical. Okay, let's go back. Square root of 9 is 3. This 3 is going to stay underneath the radical because it's not a perfect square number. This x is going to come down. Now what I want to start doing is circling groups of 2 for my y. So here's one group of 2, another group of 2, and another group of 2. So I've got 3 groups of those y's. So I'm going to take 3 out, and I've got y cubed. This last one here doesn't have anyone to come out with, so it's going to stay underneath the radical. Okay, so I've simplified everything. Now I want to condense this expression because right now it's looking a little messy, right? So what I can do is because this is all multiplication, I can write this all as the numbers on the outside of the radical. So I'm going to have outside the radical a 3, an x, and y cubed. So I can just write them all in front as 3x and y cubed. Now with the things left underneath the radical, the things that are root 3 and root y, I can write it as one single radical and just put those things underneath. So I've got 3y. And this is your final answer. Okay. There are problems like this on homework number 5, so go ahead and try them. They are the last 2 problems. If you have any questions, feel free to attend our office hours. Don't forget to like, subscribe, and comment down below. Thanks, guys.